Hello mga Ka Acute Angels! Welcome back for another Mathinic episode. This is Teacher Mika
And this is Teacher Joyme.
Today, we will learn about translating English phrases to mathematical phrases and English sentences to mathematical sentences and vice versa.
After going through this module, you are expected to translate English phrases to mathematical phrases and English sentences to mathematical sentences and vice versa. Moreover, you are expected to illustrate and differentiate related terms in algebra. A sub n, where n is a positive integer, constants and variables, literal coefficients and numerical coefficients, algebraic expressions, terms and polynomials, number of terms, degree of the term, and degree of the polynomial.
But before we proceed to our discussion, let us have a game first entitled It's a Sign. Symbols are often used in real life to express a message. Now, I will flash a symbol and all you have to do is guess what the symbol is for. Are you ready? Alright, first one. What do you think this road sign is for? Okay, very good. This means no U-turn. Next, how about this one? Alright, this symbolizes a rule for no smoking. The third one? Very good. This pictures pedestrian crossing. And how about this? Correct. This is for no parking. And lastly, in mathematics, what do these symbols mean? Yes, these obviously are the four fundamental operations, which are addition, subtraction, multiplication, and division. Now, it's time to translate English phrases to mathematical phrases and English sentences to mathematical sentences and vice versa.
The four fundamental operations of mathematics are represented by these symbols. These are addition, subtraction, multiplication, and division respectively. However, aside from add, subtract, multiply, and divide, we can also use other words to express these mathematical operations. What are these words?
Here's the list of words that could translate into each of the mathematical operations. For addition, we have add, increased by, less, sum, total, more than, and altogether. For subtraction, we have subtract, decreased by, minus, difference, reduced by, less than, diminished by, and take away. For multiplication, we have multiply, product, times, of, and per. And lastly, for division, we have divide, quotient, shared, split between, divided by, and ratio of.
We also have other symbols, especially in translating English sentences into mathematical sentences. These are less than, more than, or also called as greater than, less than or equal to, also called as at most, greater than or equal to, also called as at least, and not equal to.
Let's now have the examples on translating English phrase into mathematical phrase and vice versa. Number 1. The English phrase is sum of 3 and 4. Our keyword is sum, which implies addition. Thus, its mathematical phrase would be 3 plus 4. Number 2. 10 decreased by 7. Decreased by is the keyword which means subtraction. Make sure to pay attention to the order. The number 10 comes first, meaning it is the minuend, and 7, which comes second, is the subtrahend. Its equivalent then would be 10 minus 7. Number 3. A number less than 11. Be careful when dealing with the keyword less than. The subtrahend will be the quantity that comes before the keyword less than, and after it will be the minuend. In other words, we are going to subtract the unknown number from 11. Thus, we have 11 minus x. Number 4. 6 times 5. The keyword is times, meaning multiplication. Number 5. 12 split between 2. Split between implies division. Hence, we have to divide 12 by 2. Number 6. 9 more than twice 8. We are going to divide this phrase into two parts. The word twice means we are going to double the number or multiply by 2. Whatever the product, we will add 9 to it. Mathematically, it would be 9 plus 2 times 8. Number 7. The product of a number and 2 divided by 3. In this phrase, we have two keywords, product and divided by. Take note that we have an unknown number wherein we can use any letter in the alphabet. Multiply first the unknown number, so let's say that is 2x, and then divide the product by 3. Thus, it will be written as 2x all over 3.
How about the examples on translating English sentence into mathematical sentence and vice versa? Let's have the English sentence. Thrice a number less 5 is 50. Note the three keywords used: thrice, less, and is. Thrice means you have to multiply it by 3 to a number that we don't know yet. We can use any letter to represent it. We then use x. And less means subtract. Also, the word is represented by equal sign or equals. Therefore, our mathematical sentence will be 3x minus 5 is equal to 50. Another example. A number minus x is 10. Take note of the keywords used. Minus means the operation to be used is subtraction. Is means equal. The word number means a value that we don't know yet. So we will use any letter to represent it. In this case, we will use x. So therefore, our mathematical sentence will be x minus 6 is equal to 10. Let's have 6 added to 9 is 15. Take note of the keywords used. Added means the operation to be used is addition, and is means equal. Therefore, our mathematical sentence will be 6 plus 9 is equal to 15. Another example. 4 times a number is equal to 16. Note the phrase 4 times a number. That means we will multiply 4 to an unknown number which can be written using any letter equals 16. So therefore, our mathematical sentence will be 4x is equal to 16. Let's have the quotient of 64 and 8 is 8. the word quotient was used, and so the operation is division. Therefore, our mathematical sentence will be 64 divided by 8 is equal to 8. Another example, twice a number minus 11 is greater than 20. Let's analyze every part. Twice a number means we will multiply 2 to a number that we don't know yet, so we will use the letter x. Minus 11 means we will subtract 11 is greater than 20. Means we will use the symbol for greater than before 20. Therefore, our mathematical sentence will be 2x minus 11 is greater than 20. And for the last example, 3/4 of a number is less than or equal to 24. Let's analyze the phrase 3/4 of a number. The word of was used to multiply 3/4 to a number that is unknown. So we will represent it by the letter x. The phrase is less than or equal to 24 means we will use the unequal symbol before 24. So therefore, our mathematical sentence will be 3/4 x is less than or equal to 24.
For the second part of our discussion today, we will illustrate and differentiate related terms in algebra.
Let's start with algebraic expression. It is the combination of variables, numbers, and at least one arithmetic operation. For example, 3x plus 5y minus 10 is an algebraic expression. This algebraic expression consists of different parts, such as numerical coefficients, which are positive 3 and positive 5, variables, which are x and y, constant, which is negative 10, and terms, which are positive 3x, positive 5y, and negative 10.
Now, let us break down the algebraic expression into its parts, and we will start with the term. A term is either a single number or variable, or numbers and variables multiplied together. Example, number 1. In x squared plus 3y plus 5, the terms are x squared, 3y, and 5. Number 2. In negative 5y cubed plus 2xy minus 4, the terms are negative 5y cubed, 2xy, and negative 4.
Literal coefficient is a variable including its exponent. Examples: in x squared plus 3y plus 5, the literal coefficients are x squared and y. Example number 2, in negative 5y cubed plus 2xy minus 4, the literal coefficients are y cubed and xy. Numerical coefficient. It is a constant multiplier of the variables in a term. For example, in x squared plus 3y plus 5, the numerical coefficients are positive 1, positive 3, and positive 5. Note that if you don't see any number in front or before the literal coefficient, the numerical coefficient will always be 1. Example number 2. In negative 5y cubed plus 2xy minus 4, the numerical coefficients are negative 5, positive 2, and negative 4.
Variable. A variable is a symbol for a known number or numbers. It is usually a letter like x or y. But take note that we may also use any letter in the alphabet. Example, number 1. In x squared plus 3y plus 5, the variables are x and y. Number 2. Negative 5y cubed plus 2xy minus 4, the variables are also x and y. Constant. It is a symbol which has a fixed numerical value. Examples. Number 1. In x squared plus 3y plus 5, the constant is 5. Number 2. In negative 5y cubed plus 2xy minus 4, the constant is negative 4.
And lastly, degree. The degree of each term is the sum of the exponents of the literal coefficient. For example, in x squared plus 3y plus 5, the degree of x squared is 2 because it has an exponent of 2. The degree of 3y is 1 since the exponent is 1. And the degree of 5 is 0 since the degree of constant is 0. Therefore, the highest degree of the expression is 2. Example number 2. In negative 5y cubed plus 2xy minus 4, the degree of negative 5y cubed is 3, since the exponent of the literal coefficient is 3. The degree of 2xy is 2, because the exponent for x is 1, and the exponent for y is also 1. We get the sum, we have 2. The degree of negative 4 is 0.
It's activity time again, and your task is to complete this table. The first item was already done for you. For expression 3x plus 4, the terms are 3x and 4. The literal coefficient is x, the variable is also x, the numerical coefficient are 3 and 4, the constant is 4, and the highest degree of the expression is 1. You will be given 3 minutes to finish the remaining 4 items. Your 3 minutes start now. Time's up. Let's check your answers. For the expression 2m squared minus 5m minus 2, the terms are 2m squared, negative 5m, and negative 2. The literal coefficient are m squared and m. The variable is m. The numerical coefficient are 2, negative 5, and negative 2. The constant is negative 2, and the highest degree of the expression is 2. For the expression 8x squared y minus 2xy minus 3, the terms are 8x squared y, negative 2xy, and negative 3. The literal coefficient are x squared y and xy. The variable are x and y. The numerical coefficient are 8, negative 2, and negative 3. The constant is negative 3, and the highest degree of the expression is 3. For the expression 6m cubed minus 2m plus 5, the terms are 6m cubed, negative 2m, and 5. The literal coefficients are m cubed and m. The variable is m. The numerical coefficients are 6, negative 2, and negative 5. The constant is 5, and the highest degree of the expression is 3. And lastly, for a raised to 7 plus 2a raised to 4 minus 6a plus 2, the terms are a raised to 7, 2a raised to 4, negative 6a, and 2. The literal coefficients are a raised to 7, a raised to 4, and a. The variable is a. The numerical coefficients are 1, 2, negative 6, and 2. The constant is 2, and the highest degree of the expression is 7.
Next up will be polynomial. Polynomial comes from the word poly, meaning many, and nomial, meaning terms. It contains two or more algebraic terms. It is an algebraic expression that represents a sum of one or more terms containing whole number expression on the variables. Note that an algebraic expression is not a polynomial if the exponent of the variable is not a whole number. The variable is inside the radical sign, and the variable is in the denominator. Let's have some examples. Number 1. 4x squared is a polynomial since the degree of the term is a positive integer. Number 2. 3y cubed plus 5x squared is a polynomial since the degree of 3y cubed and 5x squared is 3 and 2 respectively. Number 3. Square root of 43 x squared minus 8x plus 3 is a polynomial since the degree of every term is positive integer. Number 4. Square root of 5x minus 2x squared is not a polynomial because the variable is inside a radical sign in square root of 5x. And lastly, negative 7y raised to negative 3 plus 6y squared minus 12 is not a polynomial because negative 7y raised to negative 3 has a degree of negative 3, which is not a positive integer.
We also have types of polynomials according to the number of terms, and these are monomial, binomial, and trinomial. A monomial is a polynomial which contains only one term. Examples are 3x, -10, and 6xy. Binomial is a polynomial expression which contains exactly two unlike terms. It can be considered as a sum or difference of two monomials. Examples: 2x plus 4y, x raised to 4 minus 3xy, and xy squared plus 6x. Trinomial is an expression which is composed of exactly three unlike terms. Examples: x raised to 4 plus 3x squared minus 3, 3y raised to 5 minus 3xy minus 18, and x cubed plus 12x squared plus 9x. Note that if it has more than three terms, it will be generally called as multinomial or polynomial.
How do we determine the degree of a polynomial? Degree of a polynomial is the highest exponent or the highest sum of exponents of the polynomial. It is the total number of times its variable occurs as factors. For instance, a monomial -5x cubed y squared z has a degree of 3 for the x, plus 2 for the y, and plus 1 for the z. So therefore we have 6. A polynomial 4x squared y plus 3x squared y squared minus 2x cubed y squared minus 1 has degrees of 4x squared y is 3, 3x squared y squared is 4, negative 2x cubed y squared is 5, and negative y is 1. Therefore, the degree of the polynomial is the highest degree of its terms, which is 5.
Moreover, here are the things that we should consider when dealing with the degree of a polynomial. Number 1. The degree of a term that has only one variable is the exponent of that variable. Number 2. The degree of a polynomial that has only one variable is the highest power appearing in any of the terms. Number 3. The degree of a term that has more than one variable is the sum of the exponents of the variables. Number 4. The degree of a polynomial in more than one variable is the highest sum of the exponent of the variables in any of the terms.
Examples: 3y raised to 5 minus 3xy minus 18. The degree of polynomial is 5. Next, negative 2x squared y squared plus 3x minus 10. The degree of polynomial is 4. Another, 7a squared. The degree of polynomial is 2. And xy cubed plus y squared minus 5x squared minus 11. The degree of polynomial is 4.
After we determine the degree of the polynomial, we can now classify it according to its degree, such as constant. This is a polynomial of degree 0. Next, linear. This is a polynomial of degree 1. Next is quadratic. This is a polynomial of degree 2. We also have cubic, which is a polynomial of degree 3. And quartic, which is a polynomial of degree 4. Also, quintic, which is a polynomial of degree 5. The next degrees have no universal name yet, so they are just called polynomial of degree, let's say 6, 7, 8, 9, 10, and so on.
Take note that the standard form of polynomial means that the terms are arranged from highest degree to lowest degree. For example, 2m squared minus 5m minus 2. In polynomial, the leading term is the term with the highest exponent and the leading coefficient is the numerical coefficient of the leading term. Example, 2m squared minus 5m minus 2. The leading term is 2m squared and the leading coefficient is 2.
For your last activity and to check your understanding on polynomials, complete this table by determining the standard form, leading term, leading coefficient, degree, type of polynomial according to the number of terms, and classification of polynomial according to degree. The first item was already done for you. Given the polynomial negative 4k squared L plus 3k plus 9L minus 5, its standard form is just the same, negative 4k squared L plus 3k plus 9L minus 5. Its leading term is negative 4k squared L. Its leading coefficient is negative 4. The degree is 3. The type of polynomial according to the number of terms is polynomial, and the classification of polynomial according to degree is cubic. You will be given 3 minutes to finish the remaining 3 items. Your 3 minutes start now.
Let's check your answers. For negative 3 plus 10x squared, the standard form is 10x squared minus 3. The leading term is 10x squared. The leading coefficient is 10. And the degree is 2. The type of polynomial according to the number of terms is binomial. And classification of polynomial according to the degree is quadratic. Next, 13a raised to 5. The standard form is also 13a raised to 5. The leading term is 13a raised to 5. The leading coefficient is 13. The degree is 5. The type of polynomial according to the number of terms is monomial. And The classification of polynomial according to the degree is quintic. And lastly, negative 5x plus 7x squared minus 8x cubed plus 1. The standard form is negative 8x cubed plus 7x squared minus 5x plus 1. The leading term is negative 8x cubed. The leading coefficient is negative 8. The degree is 3. The type of polynomial according to the number of terms is polynomial. And the classification of polynomial according to the degree is cubic.
That ends our lesson today. We hope you learned something. See you on our next episode, Ka Acute Angels. Keep safe!